Welcome to the Walton Pi. Today we're going to go through a couple examples of implicit differentiation and how to use it in practice. Alright, so let's get started with a couple equations. So let's say that we have y squared x plus cosine of xy equals 13x cubed. Let's say that we are trying to find what is dy dx. So we can't really solve for y in this case. It would be very tricky to do so. So what we are going to have to do is we are going to have to be using implicit differentiation to be able to find dy dx's using the chain rule and product rule and all of those different rules together, and then we are going to try and solve for dy dx. So if we were to take the derivative of the entire expression with respect to x, what we are going to do is we are going to have a whole bunch of product rules and chain rules come out. So the derivative of y squared x, that's first times the derivative of the second, so we get a y squared times 1, plus the second times the derivative of the first. So the derivative of the first is 2y, but y is a function of x, so the chain rule says that we are going to get a dy dx coming out from there as well. So that is the derivative of y squared x. The derivative of cosine of xy, we're going to be using the chain rule and product rule as well. So the derivative of cosine is negative sine, so that we are going to get negative sine of xy times the derivative of the inside. First times the derivative of the second, so we get x times dy dx plus the second times the derivative of the first. So that is one side, and the other side is going to give us a 39x squared. What we can do now is we have dy dx's, and we are going to try and solve for those. So we get a 2xy dy dx minus an x sine of xy dy dx y squared and a minus y sine of xy is all equal to 39x squared. We are going to keep the two terms that have a dy dx on them and move the other terms to the other side. So we are left with a 2xy minus x sine of xy times dy dx is equal to 39x squared minus y squared plus y sine of xy. And if we want to solve for dy dx, well, we are going to divide by this term. So what we can do is if we move all of these to the denominator over here, what we are left with, that is what dy dx is going to be equal to. Alright, for our next example, let's say that we are trying to find dy dx when we are looking at the relation cosine squared of inverse sine of x plus 3y is all equal to y to the fourth. Let's walk through how we would be able to figure out dy dx in this case. So we have the derivative with respect to x of all of that, and we are going to get the derivative of the outsidemost function, well, 4y cubed dy dx. So let's figure out the other side. Of cosine squared, that is going to be a 2 times cosine of all of that inside, inverse sine of x plus 3y times the derivative of cosine is a negative sine of inverse sine of x plus y, close that one, times the derivative of inverse sine of x plus y. So if we don't know what the derivative of inverse sine of x plus y is, we are going to have to figure that out. So we want to figure out what the derivative of inverse sine is going to be. So if we have inverse sine of x equals y, then that means that x equals sine of y. So if we take the derivative of both sides, That's going to give us 1 equals cosine of y dy dx. So dy dx is equal to 1 over cosine of y. So let's see, we got 1 over cosine of y, so that is 1 over cosine of inverse sine. So let's see, so we know x equals sine of y, so if that is y, x is sine. Sine is opposite over hypotenuse, so we can make that x. That is 1. This is the square root of 1 minus x squared. So cosine of y is 1 minus x, the square root of 1 minus x squared. So this is going to be 1 over the square root of 1 minus x squared. So that's the derivative of inverse sine. So what we can do is we can say the derivative of this is going to be times, we have a 1 over the square root of 1 minus the insidemost piece squared, 1 minus x plus 3y squared. That's the derivative of inverse sine. Now we have to take the derivative of the inside piece of that, so that is going to be a 1 plus 3 dy dx. So that is an absolute mess of stuff. Now, fortunately, all we have to do is try and solve for the dy dx. So we have a dy dx here and a dy dx here, which is nice, but that's still going to be quite a bit of stuff that we have to go through and do. Now, fortunately, a couple of these pieces will cancel. So negative sine of inverse sine of x plus 3y, all of that can simplify to being negative x minus 3y. So that makes that part a little bit nicer. We can also do cosine of inverse sine of x plus 3y. So we have x plus 3y is going to be our ratio. So some angle theta, we have x plus 3y here. We have 1. This is going to be the square root of 1 minus x plus 3y squared. So cosine of that is the 1 minus x plus 3y squared under the square root. So what we are left with is we got a 2 times cosine of that angle is going to give us that square root. 1 minus x plus 3y squared times negative x minus 3y times 1 over the square root of 1 minus x plus 3y squared times 1 plus 3 dy dx is equal to 4y cubed dy dx. Now, this term cancels with this term, which makes our lives much, much nicer. So we are left with negative 2 minus 6y, or negative 2x minus 6y, times 1 plus 3 dy dx equals 4y get a negative 2 minus 6y plus, or let's see, minus 6x dy dx minus 18y dy dx equals 4y cubed dy dx. Move these two terms to the side, and we are left with negative 2x minus 6y equals dy dx times 4y cubed plus 6x plus 18y, and then we can divide all of that over to the other side. So that is going to move that over here, all over that, and that is what dy dx is going to be equal to. Which we could do a little bit of simplification by dividing everything by 2. So it's negative x minus 3y all over 2y cubed plus 3x plus 9y. That is our answer for dy dx. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.